Hi, I'm Reshma Raj from Civil Engineering Department of SNS College of Technology. Today, in this video, I'm going to talk about concrete technology. And as you all know that concrete technology means the concrete. The concrete plays a very important role in buildings for building massive structures as well as so concrete nowadays is the prime material for building any kind of buildings. So this concrete, let us begin with the definition of concrete. Concrete is the most commonly used man-made material in earth. It plays a key role in almost every kind of construction, be it buildings or roads or bridges or even like massive infrastructure, uh, like massive infrastructure like projects like dams, everything. So what exactly is concrete? Actually, it is essentially a mixture made from uh, three key components. The main component of concrete is the binding material. We can able to talk about it like it is cement. So cement is the primary binding material. Other than that, aggregates which include it is like fine particles called it as sand, as well as coarse particles we can call it as gravels, and another prime ingredient is water. So when these three ingredients are mixed in a proportion, a chemical reaction takes place. That chemical reaction is called as hydration. So the reaction, this chemical reaction allows the cement to bind the aggregates together and hardens into a very strong material. So it is very strong it is, and the material is very durable, and the this simple yet very powerful mixture is the reason concrete is such a widely used and trusted material across the globe. And depending upon the material of using in concrete, we can term or we can classify concrete. So there are so many several classification, but right now I'm going to talk about only very important main four types of concrete. The first one is cement concrete. It is the basic concrete, is the basic level of concrete. So if it is a concrete, that is the basic is the cement concrete. So the first type, why I'm talking about it as a first type is because it is the most basic and commonly used form, made by mixing cement, sand, coarse aggregate and water in definite proportion. Depending upon the proportion, the strength, everything will change. Next, I'm going to talk about the lime concrete. So here the primary binding material instead of cement, here it is used as lime. So we can't able to expect to build a very massive structure by using lime concrete, but still ancient people were built it. But right now we are using as a strong material because it's cement. Lime we can use it as in history times. In historically it is used for many kind of purposes, but right now we are not using so far. And next important one is comes under the RCC. So what is RCC? RCC is known as reinforced cement concrete. Concrete by nature is very strong in compression but very weak in tension. So to overcome this weakness, steel rods or bars are embedded or infused into the concrete. This reinforcement greatly improves its tensile strength, making RCC the most widely used type in modern construction, especially in beams, slabs, and columns. So, and the next kind type is pre-stressed cement concrete. widely used in massive structures. In this method, the concrete is placed under compression even before it starts carrying loads. This is done by tensioning high strength steel tendons. Tensioning means it is twisting, so it gets tensed, and if you are pouring the concrete, concrete will be under compression. So this tendons, because of this tendons within the concrete. So by pre-stressing, the concrete performs much better under heavy loads. And this type of is often used in large scale projects like budgets and flyovers where strength and durability are critical. Next comes the uses of concrete. There are several uses of concrete. Here I'm talking about only very important three uses of concrete. The first one is structural elements. So in buildings, it is used in structural elements like footings and uh, columns, beams, slabs, and roofs. Essentially, concrete provides that backbone for the entire structural framework. Apart from buildings, concrete is also heavily used for storage structures such as water tanks, silos, bins, and bunkers. The, these structures need to be both watertight and durable. Concrete mm, and concrete serves the purpose very well. On a much larger scale, concrete is the material of choice for massive civil engineering projects like bridges, dams, and retaining walls. These structures require immense strength and durability, which only reinforced or pre-stressed concrete can provide. So, whether it is something as small as pavement or as huge as dam, concrete finds its place everywhere in construction. Actually, next we can talk about the benefits. Concrete has many advantages that makes it more preferred building material. Firstly, it is relatively cheap compared to other materials like steel, yet it has a long lifespan. Once constructed properly, concrete structures require very little maintenance. Secondly, it is very strong in compression, which means it can withstand at heavy loads. This makes it ideal for foundations and large structures. Another big benefit is that before concrete hardens, it is in a semi-liquid or plastic state. This means it can be poured into molds and shapes into almost any form or size, whether it is a simple block, a decorative panel, or a complex structure component. Lastly, concrete is a non-combustible. This means it does not catch fire, can actually help in uh, contain fire within the building. So this property gives concentrate concrete structure uh, additional safety precaution advantage compared to other like wood. So here when we can able to talk about the limitations, um, yes, it is the first limitation is it is strong in compression means the it is weak in compression. So I mean it's strong in compression means weak in tensile stress or tension. So that is the first one. It is very less in tensile strength. It cannot elastify itself. It is, if you build it is for a perfect shape, it can't expand or any changes happening, we can't do that after it get hardened, but during its semi plastic time we can able to make it up also. Then low ductility, of course, tensile strength and ductility is equally, I mean, directly proportion. So if tensile strength is less means ductility will obviously is less, and compared to low strength to weight ratio, this means that while it is strong, it is also quite heavy compared to its strength. That is why steel is still the preferred material when compared to the sizes. And finally, the concrete is prone to cracking. This may happen due to shrinkage, temperature change, or extension loads. This is why steel is the preferred material because it has the tensile strength. Strength is more important after all. And finally, concrete is outstanding construction material. Whatever limitations we have, engineers will always prefer to be more aware of its limitations, but though it will the engineers will prefer concrete other than any other material, and take reinforcement proper. There are certain things we have to take care, like proper caring, proper curing, proper maintenance. If you are taking care of these things very well, means it can be that building will be sustained for many long many years. Thank you.